Hello, dear Algebra 2 students. This is section 5.6. We're going to be talking about two specific theorems today called the remainder theorem and the factor theorem. So we're continuing our idea of polynomial functions and how we can find out about them. Today we're going to be talking about something called synthetic substitution, which is a new way to evaluate functions. And then we're going to use synthetic division to figure out whether or not a binomial is a factor of a polynomial. And again, we're going to use synthetic substitution. So what we're going to start with, first of all, you should be looking for these words or phrases as we go through the PowerPoint: synthetic substitution and depressed polynomial. Those are your new vocab words for this section. Synthetic substitution, we're going to start by talking about what this is. Basically, synthetic substitution means that we use synthetic division to find the value of a function. So for example, I have this function, f of x equals negative 3x squared plus 5x plus 4. What happens if we divide it by x minus 3? Well, here they show us method number 1 using long division, and notice I get a remainder of negative 8. Method 2 using synthetic division, here are my coefficients, negative 3, 5, and 4 written out here. Brought down the negative 3, multiplied it by 3, got negative 9, negative 4 times 3 is negative 12, and I get the same remainder of negative 8. So notice I put the 3 here because my binomial I'm dividing by is x minus 3, so the 0 or the root is 3 that I divide by here. So let's look, both of these cases we got a remainder of negative 8. Let's compare to what happens when I evaluate this function at 3. So notice here, I was using the 3 for division. I'm going to say what happens when I plug 3 into my original function f of x. Well, that's negative 3 times 3 squared plus 5 times 3 plus 4. That's negative 27 plus 15 plus 4, which is negative 8. Notice that f of 3 equals negative 8, which is the same as the remainder when I divide by x minus 3. That is an illustration of what we call the remainder theorem. So for example, if I wanted to evaluate f of 4, I could either plug 4 into my polynomial and evaluate it, which is what we've done before, or I could do synthetic division with 4 instead of 3, and my remainder would be the same as what I get when I plug 4 into my polynomial. The remainder theorem says this: if I take a polynomial p of x and I divide it by a binomial, x minus r, the remainder is going to be some constant, okay? And that constant is going to be the same as if I plugged r in to my original polynomial. So I get my quotient times my divisor plus the remainder gives me my original polynomial, right? So for example, if I take x squared plus 6x plus 2 and I divide it by x plus 10, so if we were going to write out what this would look like, and I were to divide this by x plus 10, we would get x minus 4, and my remainder would be 42 over x squared plus 6x plus 2. So if I do x minus 4 times x plus 10, and then I add 42, I will get back to my original polynomial. And this 42 is the same as my original polynomial evaluated at negative 10. That's called synthetic substitution. So when we apply the remainder theorem and we use synthetic division to evaluate a function to find the value at a certain point, we call it synthetic substitution. It's a pretty fast way to do that, especially when the degree of the polynomial is bigger than 2. It's a pretty easy way to evaluate because synthetic division is pretty fast. So let's take a look at this. If f of 6 equals 2x to the 4th minus 5x squared plus 8x minus 7, we want to find f of 6. So we're going to talk about two ways to do that. The first is using synthetic division. By the remainder theorem, f of 6 is what we get when we divide the polynomial by x minus 6, x minus whatever number I'm evaluating at. So when I do synthetic division, I put in all of my coefficients here. 2, 0, notice this 0 goes in for 0x cubed because there's no x cubed term. Negative 5, 8, and negative 7. Let's bring down the 2. 2 times 6 is 12. 0 plus 12 is 12. 12 times 6 is 72, and so on until I get my remainder of 2,453. That means that f of 6 equals 2,453. And we can prove that by looking at our second method, which is just direct substitution. So I just say, okay, if f of x is this function, then when I plug in 6 for x, I find f of 6, I get 2,453. So I get the same answer either way. All right, I want you guys to try this one. All right, the answer should be 34. And here's the work for that. In green, you can see the synthetic substitution work where I do synthetic division using the 3. And my remainder is 34, so f of 3 equals 34. Direct substitution, I just plug 3 in for x, and I get the same thing. That's how I can check. Okay, let's take a look at this example here. It says, the number of college students from the United States who study abroad can be modeled by the function s of x, which is this, where x is the number of years since 1993. That's going to be important. And s of x is the number of students in thousands. How many U.S. college students will study abroad in 2011? Well, let's look at what they did here. Where did they get the 18? So basically we're saying that I need to evaluate the function x at the year 2011. I need to evaluate the function s at the year 2011, but I can't just plug in 2011 because x is the number of years since 1993. So how many years passed from 1993 to 2011? 18 years. So I need to evaluate the function at 18. I can either plug 18 in for x, or we can do synthetic substitution, which is what they're doing here. So I do synthetic division with 18, and then these are all of the coefficients of my function. My remainder is 451.76. So that means that in 2011, 18 years after 1993, there will be about 451,760 U.S. college students studying abroad. Remember, it said that s of x is the number of college students in thousands. So this has to be 451.76 thousand, which is 451,760. Okay, you guys try this one, please. Okay, the answer here should be B, 638,680 students. All right, let's go on to the next back page of your notes here, and we're going to talk about the factor theorem, which is the other big focus of this section. So I want you to take a look at what's happening here. Here I'm doing synthetic division. This is my original polynomial. I'm dividing by x plus 3, and the answer I get is 2x squared minus 9x plus 10. So since I'm dividing by x plus 3, I put a negative 3 here. 2, negative 3, negative 17, and 30 are my coefficients. I do synthetic division, and notice that my remainder is 0, right? So this polynomial that I got as my answer that came from these coefficients is called the depressed polynomial. Why? Because the original degree was 3. My new degree is now 2, so the degree went down to it was depressed by 1. It has a degree that is 1 less than the original polynomial. That's called a depressed polynomial. So, because I know that this was my original polynomial, 2x cubed minus 3x squared minus 17x plus 30, I know that that has to equal the quotient times the divisor plus the remainder. So if I take x plus 3 times my answer, 2x squared minus 9x plus 10, I get my original function. And in this case, my remainder is 0. Since the remainder is 0, I know that if I were to plug negative 3 into my original polynomial, I would get 0. So since negative 3 is a 0, or an x-intercepts, x plus 3 has to be a factor. So anytime I get a remainder of 0, that means that what I divided by, in this case, x plus 3, my divisor, is a factor of my original dividend. So the binomial x minus r is a factor only if my remainder, or what I get when I plug r into my polynomial, is 0, which makes sense. So let's take a look at this. We're going to figure out whether or not x minus 3 is a factor of x cubed plus 4x squared minus 15x minus 18. Remember, if it's a factor, when I do division, I have to have a remainder of 0. So we're going to do synthetic division. So since my divisor is x minus 3, I put a positive 3 here. These are the coefficients, 1, 4, negative 15, and negative 18. Those are the coefficients of the dividend. Bring down the 1. 1 times 3 is 3. 4 plus 3 is 7. 7 times 3 is 21. Negative 15 plus 21 is 6. 6 times 3 is 18. And when I add that to negative 18, I get a remainder of 0. So that means, let's come back here for a second, that x minus 3 is a factor. So x minus 3 times, what is the depressed polynomial represented here? X squared plus 7x plus 6. So x minus 3 times x squared plus 7x plus 6 is equal to my original polynomial, x cubed plus 4x squared minus 15x minus 18. It's the exact same thing as if I say, well, okay, 18 divided by 3 equals 6. That means that 6 times 3 has to equal 18, right? So this is a factored form of my original polynomial. Now I have to see if I can continue to factor this part. And I know x minus 3 is one factor because I got a remainder of 0. Now I'm going to find the remaining factors. I'm going to see if I can factor x squared plus 7x plus 6. So when I check that, it turns out if I look for two numbers that multiply to 6 and add up to 7, that'd be positive 6 and positive 1. So x cubed plus 4x squared minus 15x minus 18 is x minus 3 times x plus 6 times x plus 1. Remember in the step before we had x minus 3 times x squared plus 7x plus 6. X squared plus 7x plus 6 factors into x plus 6 times x plus 1. So this cubic polynomial completely factors down this way. And one more thing. Since these are the factors, I can tell what the zeros of the function will be. X equals positive 3, x equals negative 6, and x equals negative 1. So this function has 3 zeros or 3 roots, 3 real x-intercepts. All right, and if we were to graph this, we would confirm that it crosses the x-axis at negative 6, at negative 1, and at positive 3. So we can confirm that by graphing. And that's one of the ways we're going to use this topic or this technique is to find the zeros of polynomial functions. Okay, so I want you guys to do the same thing. Figure out whether or not x plus 2 is a factor of this polynomial. If it is, find the remaining factors. All right, in this case, you should have gotten A. And here's the work that goes with it. So here up in my first step, I'm using synthetic substitution to figure out whether or not my remainder is 0. So if x plus 2 is a factor, then when I do synthetic division, right, putting my root here, my negative 2 here, my remainder is 0. So that means that x plus 2 is a factor. So that's here. My depressed polynomial is x squared plus 6x plus 5. So x plus 2 times x squared plus 6x plus 5 equals my original polynomial. Now I'm going to see if I can continue to factor. In this case, x squared plus 6x plus 5 does factor into x plus 5 times x plus 1. So notice here in our answer it's yes, x plus 2 is a factor, and the remaining factors, meaning the other two factors that are not x plus 2, are x plus 5 and x plus 1. All right, that's the end of this section. I will see you in class to practice.